Welcome to lesson 17.1. In this series of lessons, we'll look at what are called computational methods. That's the kind of thinking that can be supported by a computer, or where a person is using the sort of logical thinking that a computer would employ. In this lesson, we'll think about, in general terms, what computational methods are and how to check whether a problem is the kind of problem that can be solved by computational methods. We'll look at the advantages and limitations of using computational methods, and we'll go through a worked example. Computational methods basically are the kinds of actions that a computer can do, or the sorts of processes that a computer can carry out. Of course, computational methods existed before computers existed. Computers are just tools that help us to implement these methods more quickly and accurately than we could do if we were just trying to work things out in our heads or on paper. In short, computational methods are logical or numerical ways of processing information to get accurate results. Many things that are important in human life are not strictly computational. So we're not trying to imply that being computational is the best thing or is the only thing. For example, when we have to make a moral choice, when we have to understand somebody else's emotion, when we are creative, when we're thinking about things that aren't readily quantifiable or are ambiguous, many of the most important aspects of human life, such as art, spiritual feelings, compassion for each other, these are not computational. So we're not trying to imply that computational is the only important thing. Nevertheless, using computational methods is a very good way of solving a certain type of problem. What type of problem? Well, let's have a think. We may have heard of the IPO model: inputs, processes, and outputs. That defines typically how a computer solves a problem. So if a problem is solvable by a computer, then it probably has inputs which will be data of a type that the computer can process, numerical, quantifiable data. And we will have some idea of the type of outputs that we are aiming at. Even if we don't know what the actual output will be, we know the type of result we are trying to get. And there are steps, and these are computational style steps, which will get us from the inputs to the outputs. That's the processing. So we have to have inputs, outputs, and steps that will get us from the inputs to the outputs. Otherwise, the problem is not really the kind of problem that can be solved using computational methods. So I'm just going to use an example. Supposing there are limited supplies of a vaccine for any medical condition within a community, and the government or the community have to decide who to prioritise for those vaccines. Is this a decision that can be made using simple computational methods? Are there any advantages to using computational methods for a question like this? And are there any problems or limitations on the use of computers to solve problems like this? So this is a real problem that faces many communities and may face us again in the future. Can we use a computer to help us to decide which people within a community receive a vaccine first? So you may like to stop the video and think about this, or discuss it with other people who are around, your family or other students, depending on where you are. Okay, so supposing we fed in all the information that we had about the transmissibility of the illness, whatever it was, and who was most likely to be affected by it. For instance, does it have more serious effects on children or on old people, or in some cases, other groups within a community can be more vulnerable. And then we're going to try and prioritise groups for the vaccine. Using a computer to do this has certain advantages. It can quickly process all the numerical data that we have, use the calculations accurately, and produce results without any bias or favour to a particular group. It's acknowledged to be rational. It's just carrying out calculations, and its results are based on the inputs that we've provided. And furthermore, these calculations will be repeatable. So somebody who disagrees with us could take the same data and process it in the same way and should get the same results. So it becomes a touchstone for an accurate and reliable way to solve a problem like this. But, and you know there's a but coming, there are problems and limitations with delegating these decisions to a computer. For example, I said we all start with the same facts, but are those facts reliable? Do we have good objective data to base our decisions on? Has human bias crept in somewhere in the way that we collect or classify facts? Furthermore, are the important facts quantified in a way that we can feed them into a computer? For example, people might have different feelings about the vaccine. How can we get that data into a kind of logical or numerical form that can go into a computer? What is the logic that tells us how to prioritize or organize the facts in order to reach a conclusion? Sometimes the very processes that we build into our computer models might have errors or biases in them. Furthermore, there are a lot of issues there that is actually quite hard to express in logical and quantifiable forms. So, for example, what is more valuable? Are some lives within a community more valuable? That's a very difficult thing to even talk about. And if not, how are we going to represent? How are we going to make decisions? Are there things that we don't know that might influence the decision? Because if so, they won't have gone into our computer model. And are there important things that can't be measured? I mean, for what it's worth, I think that these decisions need human beings to input to them, not just computer models. And really here I'm talking about my own opinions, but where we can employ computers to help us to make decisions in the real world, but in order to do that well, we have to understand what a computer is good at and also what it can't do. And we almost always have to blend the use of computational methods, the processing of data to get statistical or quantifiable results, with other methods to do with an open discussion within a community about what we value and what we want to do with our resources. I've said you have to make the final choice yourself. Of course, it might not be you, but a person has to take responsibility for making the final choices. We can't just leave everything up to computers to decide. And again, this is my opinion, but I think that community decisions are better if all the human beings within that community have had their say and are involved in the decision-making process. So you probably didn't expect to discuss all these things in a computing lesson, but I think we have to show how computational methods, while valuable, are only part of what humans need to do in order to make the right decisions. So if you are my student, I've provided you with a computational methods workbook where we'll discuss some examples, and we're going to talk about case study 1, which is about predicting sales. I'm going to talk through that case study now, so even if you aren't my student, you can follow along. So what I've done is provided an exam style question. You have to discuss a statement. It is possible to use computational methods to predict the success of an app, like on a phone. You have to discuss this statement. So this would be a very typical exam style question on the topic of computational methods. So in the remainder of this lesson, I'm going to go through how we would answer that question in order to get good marks in the A-level exam. In a long answer of this kind in the A-level exam, they would expect you to demonstrate 3 areas of competence. That is, that you understand the topic, that you can apply the ideas to an example, and that you can evaluate the positive and negative aspects of the case, whatever it is. So let's go through those 3 aspects and see what we might write. So here's the question again. We have to show that we understand the issue. And the technical issue that is shown in this question, embedded in this question if you like, is the use of the term computational methods. We have to demonstrate that we understand what that means. This would be the first thing that you would typically do as you answer this question. So in order to show that we understand the topic, we need to define any technical terms that are used in the question and show that we have good factual understanding of what that term means and any implications. So in this case, I would start my answer by explaining what computational methods means, and in general terms, what makes a problem solvable by computational methods. I've already given you all the answers to that in our discussion earlier. So what I'd like you to do now is to stop this video and write down just 2 or 3 sentences that answer that question. Those 2 questions: what are computational methods, and what are the features that make a problem solvable by computational methods? Remember the input processing output model. Okay, supposing that we've written that, we now have to apply our understanding to the case study in the question. A longer question of this kind will always include an example or case study. In this case, we're applying our understanding of computational methods to the example here. We have to try to predict the success of an app. So imagine that we had the task, somebody's made an app, and I have to decide whether to invest in it, let's say, as a company. So can I use computational methods to predict whether an app will be a success or not? When we're applying understanding, which is typically the second thing that we would do as we write our long answer, look at the example in the question. So make sure you can identify what the example in the question is, in this case, the success of an app, and then apply the technical ideas that you've already discussed to the example. So what would make an app a success, and how could we use a computer to predict this? What information might we put into the computer, and how might we process that data to get the result, and what kind of result would we be looking for? So I haven't given you so much information about this because my previous example was about a vaccine. This is about an app. What does a successful, how do you know that an app is successful? Would it be sales? Would it be reviews? Would it be downloads? and what information might help us to predict that. Okay, so stop the video and have a go at writing that second part. Again, it doesn't have to be hugely long, maybe a paragraph or so. And then in order to complete the answer and to get good results, we must also try to evaluate the issues that are raised in the question. And our clue that we have to evaluate is this word discuss. When we discuss something, what they usually want us to do is to discuss the pros and cons, the good and bad points of using computational methods, and to decide whether it is possible. So we give the good sides, we give the risks and limitations, and then we decide. And there's an actual question to be decided in this topic. Is it possible to use computational methods? So whenever we evaluate, whenever we do the third and final part of the question, we have to look at the topic, look at the technical issues, and then briefly, and in an A-level it's only relatively briefly, review the benefits and the problems or risks associated with this technical topic, whatever it is. And I think it's good to give your final conclusion. You won't usually be marked down for any conclusion as long as you've given reasons to back up your conclusion. So we might talk about what's good about using a computer to predict the success of an app, but what might go wrong if we use computer methods to predict the success of the app. And if you were working for this company, what would you advise? Use computational methods or nah? What would you say? So to recap, we've talked about what computational methods are and how to spot whether a problem is solvable by computational methods. I've talked a little bit about the advantages and the limitations of using computational methods for a difficult problem, and how when we're in the exam we have to understand, apply and evaluate. And if you're wondering what my answer would be to is it possible to use computational methods to predict the success of an app, I would say it is, but they would be blended with other ways of predicting success. So we would collect data about previously successful apps and try and crunch that data to find out what made them so good. But at the end of the day, that on its own isn't going to give us guaranteed success. Okay, so I've been through two examples now, the vaccine one and the success of an app. And here's another case study. It's in the workbook if you're one of my students. Here's the question. The government wants to evaluate the performance of care homes for the elderly. This is in the news quite a lot at the moment. The government wants to evaluate the performance of care homes for the elderly. Should they use computational methods to decide which care homes are doing well? So I'll leave you with that. If you're one of my students, put your answers into the workbook, and in the next lesson we'll continue looking at the way that we can use computational methods. Bye for now.